Okay, this next question we did in class. Well, we actually did it after school, so if those people who missed it, here's a chance for you guys to get this. And if you stayed after and still don't understand it, we can go through it kind of slowly at your own pace. The number of bacteria present in a petri dish can be modeled by the function n is equal to 50 e to the 3t. N is the number of bacteria present in the petri dish after t hours. Using the model determined to the nearest hundredth the number of hours it will take for n to reach 30,700. So we want n to be 30,700 is equal to 50 e to the 3t. And what we want to do is we want to isolate the e to the 3t. So what we're going to do is we're going to simply divide both sides by 50 to get us started. And we divide both sides by 50. I can bring the calculator in. We got 30,700 divided by 50, and that's 614. So we get 614 is equal to e to the 3t. One of the things we talked about when we went over this problem, and one of the things that you guys need to know, is we need to get to that 3t. So our two choices are to get both sides so they have a base of e, and I'm not going to be able to express 614 as a base of e. So what I'm going to do is I'm going to try to get to the 3t, and the way you get to the 3t out of the exponent is you take the natural log, which is the inverse of e, of both sides. So I take the natural log of 614, and I take the natural log of e to the 3t. What happens on the left-hand side, we just get natural log of 614, and on the right-hand side, the natural log and e cancel, just leaving me with 3t. Okay, and then we're going to simply divide that by 3, and divide that by 3, and we're going to get t is equal to, and I hit natural log. The natural log key is right there, so I'm going to hit second. No, I don't want second, I just want natural log, 614, and then we're going to divide that by 3. I get 2.139 to the nearest hundred, 2.14. And there's my answer. Okay, next question. Next question is a regular log question. However, what you want to see is you only have the log written on the left-hand side. We don't have a log on the right-hand side. So if you have a question that's set up like this and we're trying to solve, the first thing you want to do is wrap and change it to an exponential function. So when we wrap, we get 5 as a base to the 3x is equal to 1,000. Now my choices are try to get 1,000 written as a base of 5, and we can't do that. So now we take the log of both sides, because I got to try to get that 3x out of the exponent. So the log will help me to do that. So this is log log. Expanding the left-hand side, the 3x comes down in front. There's my log 5 is equal to log of 1,000. And then what I want to do is I'll divide both sides by log 5, by log 5, and I get 3x is equal to, and I go to my calculator, and now I'm getting ready to go. I'm just going to plug in that log, which is there. So log of 1,000 divided by log of 5. And we get 4.29203, and then we divide both sides by 3, and I get x is equal to 4.29203 divided by 3 equals, and we get 1.43 to the nearest hundredth. And I'm done. Alright, now let's look back and see if we can check both the ones that we just did. Take just 2 minutes to do that. So we want this to make sense. So if I come back up here, just so you guys can see it and we can get some practice playing around with the calculator, when you take a look at this question, if t is really equal to 2.14, if I plug that 2.14 into that t, I should come up with something very close to 30,700. It won't be exact because we rounded. So let's give that a shot. I'm going to take this equation right here, put it in my calculator, 50. If I want to get e to my calculator, that's the natural log. Oops. That's the natural log key. What's above that is e. So I'm going to hit second, natural log. There's my e. All right, and I'm going to raise that to the 3 times my answer, 2.14. Close parentheses, hit enter, and we get something very close to 30,700. So we know that this answer is probably right. We work down to the bottom, and we work down to the bottom to check this answer out, I get an answer of 1.43. That means if I come back up to where I wrapped, which is right here, if I take 1.43 and plug it into this x value, I should get something very close to 1,000. So I have 5 raised to the open parentheses 3 times 1.43, close those parentheses, hit enter, and we get 996. That's pretty reasonable. Again, because we rounded, we're going to be off, but it's pretty close to 1,000. So that's kind of one way you can go through and check to see if your answers are reasonable with some of these questions.